This is the client-side track. You're in the Augustus 5-6 room. Today, presenting is Hacking Browsers DOM, Exploiting Ajax and RIA. The presenter is going to introduce himself. Please welcome him.
Thank you. Thank you very much. Going to talk on Hacking Browsers DOM. Before that, I will just introduce myself. I'm a founder and director of a company called BlueInfi. So we are specifically focused on application security, 8443. So everything which we do around that. Previous experience, NetSquare, Foundstone, Chase, IBM, etc. And my prime interest is web security research. So we do a lot of research on that, come up with the tools, techniques, methods, etc. And today I'm going to walk through some of the tools, and we are introducing two new tools today. DOM Scan and DOM Tracer. So we'll look at that as well, and then you can download and play around. These are some of the published research by me on security focus, O'Reilly, DevX, Inform-IT. So I'm writing some columns and stuff like that for them. These are some of the tools: WS Scanner, Scan Web 2.0, etc. So some of the tools we are going to cover during the presentation. And these are some of the books written by me on web hacking, hacking web services, and Web 2.0 security. So this is the agenda for today. We'll start with attacks and trends, very small piece where we focus on importance of the DOM and how it is coming in. We'll look at some of the cases, client side and patterns. We do a lot of assessments and audits, and we have on-demand scanning going on. So in last 2 years, we come across a lot of 2.0 applications. 50 to 60% of applications coming for the review are essentially 2.0 kind. Then we'll look at DOM and application architecture, how DOM fitting into next generation applications. So we'll look at layout, browsers, DOM attack surface, and then we actually look at DOM based attacks like DOM based XSS, widgets hacking, feeds, mashups, injections, etc. So the focus here is definitely the 2.0. So 2.0, be it flash, flags, or such. And then we briefly touch upon some of the defense and countermeasures and end with conclusions and questions. I have a lot of demos lined up, so I will try to play those demos whenever it's required. Okay, so first move on to the attacks and trends. In the last couple of years, we reviewed a lot of applications, be it banks, portals, telecom, etc. And when the application is a 2.0, which is using Ajax, Flash, Flags, Silverlight, what we are looking at is a very complex usage of DOM. DOM is essentially a document object model, which is a part of your browser's rendering component. So developers are using DOM very innovative way, dynamically changing DOM, and they are integrating a third-party libraries like say Dojo or GWT or DWR or such. So these libraries would be using this DOM in a pretty complex way. And then we detected vulnerabilities like XSS with DOM, widgets and mashups from the DOM, logic bypass, lot of different attack vectors which we defined in this area. And recently, like some of the published vulnerability, like you have a multiple DOM based XSS in Dojo toolkit, or you have a Yahoo Mail or such. So there are a lot of reporting coming out which is focused on DOM based cross-site scripting and DOM based vulnerability, and we'll see how there are no sufficient or enough tools or automation out there to address DOM based vulnerabilities as such. So we try to address that as we go. Client-side attacks are on the rise. There is a lot of statistics out there. Malware and attacks are completely focusing on the browsers, and then there are various different components of the browsers out there, maybe a plugins or maybe the underlying components or maybe a DOM. So that's a little piece which we are focusing during the presentation. DOM is an active part of the browsers, and it's essentially a popular attack point. As we know, like XSS is a major threat which we are looking at, and we have a persistent, non-persistent, and DOM-based 3 type of cross-site scripting. But with the DOM-based cross-site scripting embedded into a Web 2.0 application will become a permanent XSS, because the DOM is going to stay there for the rest of the life cycle of the application. We'll see what little difference is there. We are looking at the CSRF over 2.0 components like AMF or XML or JSON or stuff like that. So that's an interesting area which we are looking at. And some of the Web 2.0 components like say widgets or mashups or feed reader, etc., is actually opening up some of the attack surface on 2.0 applications. So this is a brief trend which we are looking at. The focus here is again a DOM, how DOM is integrated into the application, what kind of a calls it is making. So this is a trend which we are looking at. WASC, Web Application Security Consortium, comes up with some of the data, and definitely like we have a 39% cross-site scripting, and then we have information leakage, etc. And some of these things can be extracted from DOM, like maybe a DOM-based cross-site scripting or information leakage coming through the DOM calls, etc. And these are the attacks which are occurred in last year, and there is a client element there, and we'll look at how DOM has to play in this particular scenario. So this is kind of a trend which we are looking at, and definitely on the top there is a cross-site scripting, but along with there are different attack vectors which are generated from DOM manipulations and DOM attacks. If you look at the OWASP top 10 from 2004 to 2007 and 2010 and how the whole AppSec dynamics changing, we are looking at the injection on the top. We have a cross-site scripting, then we have a new introduction of say unvalidated redirects and forward. Now across these attack vectors there is a DOM which can play a role, or a DOM would be playing a role. For example, you have a injection, you have SQL injection over JSON, for example. This particular call is actually going from the DOM over API, or cross-site scripting where DOM based cross-site scripting would be playing role. Broken authentication and session management, when the functions are getting called via DOM, and if these functions are not yet already the function is already published, and once it is getting loaded in the DOM, you can make call anytime. Unvalidated redirects and forwards can be linked to a DOM. So essentially these are some of the elements where in OWASP top 10 there is a usage of document object model or a DOM. So if you look at the architecture and how DOM fits in, so here for example you have an application right here, for example a dummy application here. So this is an application where browser loads the page, loads the whole HTML page over here. So you have HTML page here, and this is a plugin called Firebug where you actually look at some of the components of your browser. So you have this HTML page here, and this is what you are looking at is all the DOM structure. So this is a document object model and all different. So every pixel over here what you are seeing can be controlled from the DOM. So you can change, manipulate anything which you want to say. For example, you want to change a value here. Say instead of a catalog you want to write something else. Programmatically you can write using DOM calls. So this is how DOM get implemented. You can start inspecting components here. For example, where this particular link is, you can see over here, or where this essential text over here, you can actually see this is okay. This is in HTML and this is in a DOM node. So this is essentially a document object model which we are looking at. So if we look at the Web 2.0 application in detail, then you have the browsers where you have a Ajax. You have a RIA, that is a Flash and Silverlight running there. You have HTML, JS, DOM, etc. So the whole browser, be it any browser you take, it's running with various different components and pretty rich in scenario. And it will make a request to the application, and assuming that this is a typical Web 2.0 application which is using DOM extensively, is going to throw a DOM, one first page DOM to the client, and then from that various different calls are going to come back and forth. So from that you can actually go and access mails, news, documents, weather, banks, trades, RSS feed, etc. So this is essentially where everything is now needed through the APIs. So you can make a SOAP API to search Google, or you can make a SOAP API to read CNN news, etc. So this is how you are going to the one application, and from that particular application you are accessing all different applications which you are accessed during your day. So we have like a internet where we have a network of networks. The 2.0 is more like an application of applications, and it is enabled with the SOAP. You can call object, and you can turn your application into the web services as well. So you publish your endpoint and your application will become a web services endpoint for someone else. So then this is the whole application architecture become very thin. You have a very thin database and authentication, and then you are trusting various different data sources and integrating them into your application via widgets or any other technology which you are using. And then you have a You have a direct calls is also possible. You can make a cross-domain bypass and make a call directly to the blog or such. So there is a whole SOP or same origin policy involved there. So this is how your DOM usage will happen, where when you load a Web 2.0 application, your DOM usage would be pretty complex, and we see how complex it can get. And when we focus on the layout, you have a rich client and web client. A rich client may be written in JavaScript, or rich client which is actually manipulating a DOM, and then you have a typical web client over there which is part of your browser, which would be you are accessing. Then you go to the DMZ, your web server is running there, you make HTML, etc. Access backend application server, it will access database, and this is how the whole 2.0 application will get access. And then you have a Web 2.0 resources sitting there, maybe web services or JSON RPCs or XML RPCs or whatever. So you have that component there, and your rich client will directly make calls to these and fetch information from the server and change the DOM. So essentially, every click you make, you don't have to reload the DOM. There is no refresh and reload the page. Once the DOM is loaded in your browser, the application will remain as it is for the rest of the time. So say, for example, you stay on that particular page and spend 30 minutes, your DOM is not going to change any time. You just make a call, it will generate a call at the back end, it will grab the information and show you on the DOM. So this is how the 2.0 DOM will interact with the 2.0 resources at the back end. So these are the few demos which I can show you here. For example, you have over here a simple application called, say, pageflags.com, and you have this Firebug running at the down over here. Now you can see in the application what is happening is things are getting loaded over here. So it's like a one-page application. It's a slash. You go to the slash and you have this particular application coming up. And over here, the calls which you are looking at is a AJAX call. They are the XHR called XML HTTP request object calls. So JavaScript will make these calls one after another. And you can see when you load this particular page, almost 130 calls which go at the back end and fetch various different information over here. So you can see all these different calls, different structures. Now some calls are going to SOAP, some calls are going to JSON, some calls are going to the weather context, etc. And you have all these different DOMs and all these different widgets. So you have like a one DOM but multiple applications running there. So this is how the application will actually work. And then if you dissect the application and try to see what is at the back end, what I'm doing over here is I'm just downloading that particular page. It's a one-page application as such. There is no second page or third page on this particular application. So it's a one DOM application. So I'm downloading the page and storing that particular page on my browser, on my local system, and then I try to run. This download is complete, so I'm taking the backend JS files as well. So I'm taking all JavaScript files, etc., from the server, and try to see what is going at the back end. So we have the page downloaded over here, and now I quickly run few commands and grab here. So I'm saying, okay, show me all JS files. So this is my list of JS files, and now I say, okay, show me all my ASMX files. So these are the ASMX files. ASMX file is essentially a backend resource for the web services. So each of these ASMX files which you are seeing is a web services by Microsoft platform which runs on ASMX. So then each ASMX file would have more than 100, 200, 300 functions. So DOM will make these calls to the ASMX files and retrieve the information what it is looking for. So this is a Microsoft technology, ASMX. Similarly, like everyone has these kind of technologies in place. For example, over here you have a DWR library, something called Direct Web Remoting Library, and at the back end you have a struts running, or struts applications running. So you can see this application, again, every time you will remain on /trade. You don't go out from the /trade. Whatever you are doing in that particular DOM only. So you can see all the XHR calls going over here. These are not the typical HTTP driver calls. These are like an AJAX call through the JavaScript. You use XHR object, make a backend connection to whatever server you are running on, and make a call and retrieve information. Whatever you want to retrieve, pretty much you are retrieving this information from the XHR call. So this is how essentially DOM is going to get utilized. So you go through the site will give you the one HTML page where the complex DOM is there, and then it will throw you 20, 30, 50 JavaScript files, and then whatever you are doing is you are playing around that particular DOM only. So this is how the browser would look like. You have a browser where you have a JavaScript, core XML parser, network graphics, etc. would be sitting, and then you have a browser engine where user security controls, data, etc. would be sitting, and some of the plugins are installed. And then you have a document object model. That's the rendering engine. That's the piece where we are attacking over here. And then you have components which are coming from the application like Ajax, Flash, Silverlight, HTML, DOM, UI logic, etc. So that get loaded in the browser, and then you start working back and forth. So this is a very higher level overview of the browser architecture, and that it differs from browser to browser. So I would have a different architecture than a Chrome. So that's something where we are looking at. And when DOM calls happen, HTML will use a JS and call XHR object. XHR object will make an asynchronous call. This is a fundamental difference between a 1.0 and a 2.0, because in a 2.0 you can make a asynchronous call. So it will wait for the callback. When callbacks comes, it will load the image or whatever you have asked for, whatever new data you have come is getting loaded in the browser. So you'll go to the web server will make a call to XML, middleware, text, etc., retrieve data resource, and then the whole thing will go back. So this is a very simple way how Ajax, Flash, or Silverlight is going to make a call, asynchronous call from browser to the server. This is the second important piece of information. We have like one information where we have one single DOM application. The second important part is there are various different structures out there in a 2.0 application. So you can use JSON, you can use JS script, JS object, XML, JS array, AMF, Microsoft remoting, serialization, etc. So once application or a DOM has a direct access to the socket level through XHR, pretty much anything can be sent back and forth. So in 1.0, our transaction from browser to server was a name value pair. So we send either in a query string or a post buffer, we send a new name value pair, say first name Shreeraj, ampersand, last name Shah, or something like that. Over here we can do a transaction in various different formats. So this is where you have a DOM get loaded, and then once a DOM is loaded, it will make a call, get the JSON stream comes, and it will inject that particular new values into the DOM wherever he wants to paste that value into the DOM. So one of the important part, or while doing the assessment, one of the part is how do you identify these DOM calls? How do you crawl these DOM calls or identify these DOM calls? So for example, over here, a very simple application we have, say for example, if I go to this particular site, say demo/crawl. Now you can see as soon as I go to the site, it is making a XHR call and grabbing these links which you can see over here. So that's the way how the application is working. Now if you look at the source of the page, over here you can't see any links because it's on. If you try to interact on the protocol layer, it's going to fail. You have to take whatever content coming and then load that content into the DOM. Once you give a context to the content, then and then things will start pop up. So over here, for example, it is saying, okay, get master.js, get dojo.js, get RSS XML parser.js, get XML HTTP request.js, and then make a function called load HTML. So load HTML will be somewhere in the JavaScript, and then there are some areas defined in a DOM, say main area and a my area, and then things will come and start getting loaded in the browser. So now this is a one-page application, so you don't have anything else. This is a page, this is a code which comes and loaded in the browser, and then all of a sudden your thin client will become a thick client because it's going to make a DOM-based calls back and forth. So then pretty much you start clicking all the links and new functions will keep on popping up over here and new things will come over here. So there is no refresh, no reload, everything is happening in the DOM via APIs. So say for example, you try to crawl this site. How do you crawl the site? Because if you open a socket connection and try to crawl, it's not going to work. So here is like, there are drivers out there by which you say, okay, programmatically you drive IE or programmatically you drive my Firefox or such. So here is a little Ruby script which say, okay, it's something called Watir. Watir is a driver for IE. You say, okay, load this link and then start clicking the links. So this will essentially what it's going to do is it will open an IE over here and then control IE from the script and start clicking these links. And you can see we are extracting these JavaScripts or calls from browser. Okay, so we introduced the first tool called DOM scan. So this tool is essentially going to drive IE for us, and going to go ahead and do this. So this is a tool, a simple DOM scan utility over here. So what we have over here is this is a DOM scan where you define which URL you want to load, and at the back end you can see IE, which is controlled by DOM scan. So DOM scan has started this particular IE instance over here, and then you say, okay, I want to go to this particular site, be it a Yahoo, Google, wherever you want to go. You say, okay, go and grab this site. So now this site is going to get loaded in the browser, as you can see, and all the links and everything which is from the DOM is going to get extracted over here. So over here you can see the extraction of the DOM over here, all the links. Here you can see the whole active DOM tree. Here is your HTML page, and then you can see you can actually control everything from here. So if I say, okay, click this particular link, the DOM of the page is going to change in the browser. So that's how it's going to control the whole interface. So now we are controlling from the tool. What we are doing is we are controlling the actual context of the DOM. So that's the first objective we want to do for the assessment, that if we come across these kind of a 2.0 sites, we should have a tools to do so. And then we can see all the JavaScripts over here, that how JavaScript is implemented for this particular DOM, and we come to the DOM scan next. So this is how the first hurdle which we can cross, where say, okay, if it's a DOM driven site, we are now control on the IE, and we can control the whole thing. So attack surface which is coming is like, if you take the client side attack surface in a browser, you have AJAX, RIA, HTML, JS, DOM, etc. And then on a server side you have query string, post name, XML, JSON, etc. So these are the typical attack surface on a server and a client side. Definitely we are going to focus on DOM calls and events, but still there is an implication of a DOM calls to the backend XML and JSON. So I will be focusing on this particular section here and this particular section over here. Else, like, there are some components which deals with the feeds and other party information over here as well. So this is our attack surface which we are looking at. Okay, moving to the DOM hacking now. So in nutshell, what we have is like now we have an application running AJAX RIA Flash. It's a single DOM application. So when you go to the slash page, the DOM is getting loaded. Your HTML page or JavaScript will get loaded. That's number one. And number two, what we have is a various different structures which are communicating with the browser and a server, be it a JSON, XML, etc. So that's the two pieces of information which we have. So now DOM-based hacking, what we have is one attack is a DOM-based XSS, DOM-based request response variable stealing. I will explain that, what I mean by variable stealing. Then we have a flash and a DOM access. So it's a cross-technology stuff which you can do. Say, for example, you get access to the DOM, and that particular DOM has a flash file running. So you start retrieving information from the flash. Feeds and mashup, CSRF with JSON, XML, AMF, etc. And then some interesting concept which I want to discuss on DOM reverse engineering. So these are the attacks which we are going to look at one after another now. So first, DOM-based XSS. It is essentially a sleeping giant. You take any AJAX application and understand it well, look at all the calls, all document.calls, all eval calls, and I'm 100% sure that you will end up finding some area where you can start injecting DOM-based cross-site scripting, or you start injecting these attack vectors. Now, what is the root cause of DOM-based cross-site scripting? The first is DOM is already loaded. So when you load the page, you have a DOM which is now already loaded in your memory. So the whole application is now on the browser side is going to run from the memory. Now, application is essentially a single page or a single DOM. So say, for example, from the point you go to the slash till the point you move out from the site, the DOM is going to remain the same. So whatever activity you are doing on the 2.0 application are going to happen on that particular same DOM. So when you make a call, what is going to happen is it will make a backend call. It will grab information, say JSON, HTML, name value pair, whatever is coming back. And now you have the memory here where the DOM is loaded, and whatever is on DOM you can see in the browser. Now this new information has come to you. You have to somehow inject that particular new information into currently existing DOM, because this is not a refresh and reload where the entire DOM is going to get reloaded. So what you're going to do is you make an eval call. For example, eval call is where you say, okay, this is a new information. I want to pass that new information to my existing DOM. So I say, okay, eval this. So that eval will actually put all the new content into the existing DOM or a memory. So this is one of the problem where this new information which is coming is maybe coming from untrusted sources. It's no longer coming from your own sources. It's not coming from your databases. So you don't know what is lying there, and then you eval that stuff, or you do document or write calls on them, and that will cause a DOM-based cross-site scripting. So this is a fundamental root cause. When you dissect DOM-based XSS and try to see root cause, one of the root causes would fall into these 4 categories. So various different way DOM-based XSS can happen. There is multiple way DOM-based XSS can happen. We'll look at the three categories over here. One is a simple DOM function using URL process or AJAX call. Second is a third-party content going into the existing DOM, or third would be AJAX call, where we remove the DOM call and directly make a call to the backend. So these are the 3 different ways DOM-based XSS can happen. So the first, say for example, you have a DOM-based URL parsing. So now what you have is your DOM is already loaded, and you want to pass on the links to different people. So you say, okay, ID equal to 1, ID equal to 2, ID equal to 3, etc. That will actually, that particular parameter is no longer going to the GET request and fetch new response for you. What is going to happen is that parameter will go to the DOM. DOM will take the parameter, make a AJAX call, grab information from the backend, and publish on your browser. So what you are looking at is you are taking information from the URL. So you say, okay, Windows location search substring or something like that, where you are saying when you start analyzing your JavaScript code, these are the calls which you start looking out. Say for example, whether I'm extracting information from Windows location or not, and then that particular value will traverse across few variables and going to hit to one of the eval call. As soon as it hits the eval call, that's the point which you get where DOM-based cross-site scripting is possible. So for example, if we do a DOM scan. Okay, so we have this particular site here, which is a catalog.aspx page. We are sitting on this. It is a completely 2.0 page over here. So all the links are essentially a 2.0. So we say, okay, scan my DOM. So we say, okay, look, show me all eval calls. So it will show you all eval calls over here. So you say, okay, this is a list of eval calls. Now what we have done over here is we took the first eval call and try to trace that in my DOM, that this particular call is coming and going from where. So the first line which we found the eval call is, say, some product function, say product, then Coco string coming. So now we are interested from where the Coco coming. So we go there and trace, and then we say, okay, line number 30, there is a file called current DOM. File name is a current DOM. And then there is a function called query st, and then there is a string which is a PID. So essentially a PID string where we are doing some kind of operation or a search. So then we start traversing into this whole thing. So we say, okay, from where this particular call is coming and going. So it may take 1 or 2 or 3 or 4 iteration depending on how the implementation is done. So now some business logic or some kind of a logic is happening, and at the end it is going to FT, and from FT to it is going to somewhere else over here. So it is going to the GY where the split is actually happening. And now we go to the HU parameter, which say, okay, now show me where is the HU parameter in my DOM. So it's okay, this is a parameter where it is doing some kind of a search substring. So now we know that there is a PID parameter which is taking from the URL and it is hitting to the eval call. So we say, okay, PID equal to 1, we can pass. Now this is going to a DOM and making a backend call to the XHR and changing information. So if I say 1 to 2, you can see the image will change over here. DOM is not, the whole page is not getting refreshed and reloaded, just that particular piece of information which is changing here. So now instead of a PID 2, now I know that this 2, the value 2, which is actually going here in the function called Coco to string, and this is the structure of that particular call. So I say, okay, over here what we have done is we go ahead and put 2 and then close the bracket, and we say, okay, we got an eval position here. So we put a semicolon and comment out rest of the JavaScript. Since this page is going to run this JavaScript, we just remove that. And now you can see we can actually go ahead and change the values or change the DOM calls over here. So now we got the point. This is place where we can start playing around here. So instead of 3, instead of a 2, if we do a 3, you can see we are looking at the third product now. So all this is happening in the DOM. Now we start injecting our script here. So we say, okay, alert document.cookie or whatever malicious script you want to inject here, you can inject and it will start executing in your current DOM structure. So this is how, interestingly, you can identify DOM and then try to exploit. So for example, if I'm already logging into the system here, and then if I do the same call here, alert document.string here, then you can see we are going to get the access to this, and we actually end up getting the pop-up with the cookie. So essentially you can start retrieving these values on a DOM based call. Now as you can see, there is no filter or anything is going to protect here. You don't have like if you have a server side filter, for example, less than, greater than, persistent, known, persistent, XSS, that is not going to work here. You need some different kind of mechanism where some kind of a filtering should happen at the DOM level on the client side. So this is how one kind of a DOM based call will work. A second is a pretty simple, where attacker posts something on the news site. For example, it's controlled by a third party. So attacker will post a news or a document or weather or etc. somewhere, and that particular piece of information will tunnel through your application and hit to your DOM, and that raw stream which is coming is not validated, it's not trusted one. It comes, you take the stream, DOM will take the stream and will do a eval, and as soon as the eval occurs, it will going to do a cross-site scripting here. So for example, once HTTP ready states, the callback will go 4, you say, okay, var p equal to eval response, and then you do document.write. Now in this particular response, if you have a live script there, then that particular script is going to get executed on the DOM. So this is how DOM based cross-site scripting will work. So you can pollute these different streams. Essentially, once attacker get a point where this kind of a pollution is possible, it will say post XML, JS object, JS array, JS script, JSON, etc. Web client will make a call to your 2.0 application. 2.0 application invoke a proxy because it can't bypass SOP. So web client directly cannot make call to the stream. So the proxy will go grab that stream and tunnel that stream into the web client, and web client will do stream in, do eval, and then cross-site script it. And there is bunch of calls out there. So it's when you do analysis of a JavaScript, you need to do document.write, document.write-ln, body, inner HTML, attach event, create, exec command, body. This is a very small list. There is a large list out there. So depending on how a developer had developed this application, for example, you take something and put it into document.write. Now, as soon as it goes into a document.write and you have an actual script going there, it's going to get executed on the browser's DOM. So this is how various different calls, these exploitable calls from a DOM can be done. So this is a very simple call. For example, if we take this is a page where we click a link over here. So as soon as we click a link, we get cross-site scripted because the information which is coming through third party has this JSON where someone has injected a script tag into my JSON. And if I look at the actual source code, how this page is getting rendered here through the DOM, then you can see over here, we are making a get JSON profile call, and then we are doing eval, and then as soon as we do document.write, this particular call will get successfully in. What you can do is, there is a little Ruby kit which we posted called scan web 2.0. So if you want to use that, essentially this is from the XML. So the same call which is coming through the XML, where we are doing a first name and last name, and then we are doing eval, or we are injecting the new content into our existing DOM. So you can see a last name, someone has injected a script here. So this is a interesting way a third party stream, be it a XML, be it a JSON coming, will cause a crash or cause a cross-site scripting, which is a DOM driven over here. And then you can actually scan the site. Say for example, you have a target application over here, you can scan that particular site over here. Say for example, if we use something called scan web 2.0. So what I'm doing here is a script called scan ajax.rb, where I define all the URLs which I want to scan, and there is no there is no yes or no here. It's a more on the static analysis or code analysis which one needs to perform. You can't say whether this is a DOM-based cross-site scripting or not. So what we are doing over here, we are looking for certain patterns. We say, okay, show me all the functions. So it'll show you all the functions, and then say, okay, show me all the XHR calls. So these are the all XHR call, and then we say, okay, show me eval, show me document.write, and then we try to correlate whether the response coming is going into eval or response coming going into document.write or stuff like that. Okay, so this is the second category of DOM-based cross-site scripting here. The third is very interesting, where you have a direct AJAX call. So you have an AJAX function which is making a backend call. Backend call would return a JSON stream or anything else, and then it get injected into DOM. This is how the application is designed. In some libraries, their content type would allow them to load directly into the browser. Say, for example, you are sending XML content. A server is library on a server side is sending XML content, but when you look at the content type, it says text HTML. Or it is sending JSON, and it's not text JSON, but it is text HTML. So if that direct stream will come and hit to the browser, then it's going to get executed. So in that case, it's essentially a bypassing DOM, and you can inject the content directly into the browser. So you can send that particular link to anyone, and then that guy will click the link. JSON will come translated as a text HTML and get executed. So for example, over here, we have a search functionality here. Now when you do a search, you can see these kind of a call going at the back end. This is a call where it says search.do parameter is some kind of a JSON stream which is going as a parameter. So we take this location and make a direct call. So now we are completely bypassing the whole GUI here, and we say we want to make a direct call here. Now instead of that, if we put a text and script alert, we get an injection point here. So this is where we are bypassing DOM. We say, okay, these are the backend calls. Now I have like all the backend calls. So that rather than going through the application, I'm saying, what if I do a direct interaction with the call, and then I inject some content into JSON and expecting the HTML is coming back or JSON is coming back. This is something which you can essentially do a trial and error and figure that out. So what you can do over here is, for example, there is a nice utility by Google called rat proxy. So if you do start a rat proxy and then you pass all your traffic through rat proxy, then rat proxy will figure out that what kind of a content mismatch you have over here, the content type mismatch you have over here. So I'm clicking all the links, so the whole traffic is going to get generated at the back end, and rat proxy will create a report for me. So then we go back over here, the proxy was started. Now I close the proxy and say, okay, generate a report, whatever log you have created so far. So it is all request and responses over here. So now rat proxy will generate a HTML page, a nice little HTML page as a report. And then you can see over here, for example, it has like type is text plain, detected is application X JavaScript, or over here text plain and application X JavaScript. So then you can identify that, okay, server is sending me JSON, but if I look at its content type, is something else. So this is one of the interesting area where we are seeing a lot of opening, and we are reporting these vulnerabilities to the clients. So that's, and some of the libraries are actually not doing this as well. So say for example, you are sending a JSON, but if you say text plain as a content type, library will go ahead and process JSON jolly well. We'll see that when we come to the CSRF with DOM-based CSRF. So in nutshell, we have covered 3 types of DOM-based cross-site scripting methods, but it is very common nowadays. Other instances are also possible, like callback directed to DOM, a little complex here. HTML5 coming up with a lot of different DOM attributes, autofocus, form action, on-form inputs, etc. You have a third-party JavaScript processing, inner HTML calls, and many other ways. So essentially, DOM-based cross-site scripting is a one type of DOM attack. Now, second interesting vector is accessing information from the DOM. So now what we have over here is an application run with a rich DOM. So when you load the application, it loads a lot of different global variables. Now say for example you go ahead and log into the Google and try to see what kind of a global variables which are loaded in the browser, and these global variables are essentially available throughout the application. So you have a DOM based cross-site scripting, and then you can start accessing these global variables depending on where your call is going. So one area is you can start extracting these globals. Second is it has a sensitive information on the variables, maybe a username, passwords, maybe it has session IDs, UIDs, etc. It can be retrieved with XSS, and HTTP request response are going. So you have a JavaScript XHR going, so you can actually steal XHR calls as well. So for example, here is a little AJAX call which say okay, get login. So there is a call called get login, and then it is doing something where it's okay, this is my username, take it from here, take it my password, open a XHR object, and then you say okay, temp equal to login.do user equal to user, password equal to pass, and then make a get or a post, whatever request you want to post. When a callback comes, you're, say for example, you're authenticated, so session cookie will set, and then you say okay, if the guy is authenticated, you say document.get element by ID main. So in my browser, wherever the area called main define, load that response right there. Now in this particular source code, you can see very casual use of temp here, this particular variable. There is no var in front. So this little variable over here is actually become a global variable. So now the temp variable can be accessed through cross-site scripting. It is out of the function access is possible. So if for example, if we go ahead and start stealing these variables, so say for example, you can start stealing user password, you can start stealing response tokens, business information can be extracted, you can actually use HTTP request and response stealing, you can create a dummy XHR object. So a lot of exploitation possibility right there. So what we have a little tool or utility created called DOM tracer. So we try to use that for this analysis. Okay, so DOM tracer is essentially a Firefox plugin which will show us the JavaScript execution here. So say for example, this is a sample page which we have over here, and we say okay, click this link. So you can when I click this link, as you can see, actual post request where JSON will go, and I get a JSON back, and then it's get loaded in my browser. Now one of the problem is that with the 2.0 application, when you load the 2.0 application, what is going to happen is it's going to load 30 files, 30 JS files for example, and when you click one particular link, 5 functions from application of .js, foo.js, 3 functions from b.js, and 5 functions from c.js are going to get executed. So what we want to look at is when I fire an event, I want to see all lines which are executed on the JavaScript, so I can do the analysis on it. So this is a DOM tracer, is a little utility which will do this for us. So it is a xpcom object which is wrapped around. So we are extracting the debug information out from it. So when we start a trace, and now we say okay, now click a link. So as soon as we click the link, whatever functions are executed, you can see over here. Okay, catalog.aspx line number 92, the function, this particular function was there, it is executed. So now you can start seeing all DOM manipulations in a JavaScript. For example, this is a document.get element is changed. Here you can see eval functions. Here is a JSON stream comes back, etc. So this is the second tool which we are posted on the net now, which you can use to leverage the analysis of a JavaScript. So you don't have to analyze, say for example, a particular application has 35 JavaScript coming. You don't have to analyze all 35. When you make a call, when you're interested, for example, if I am doing the submit button, I put on my login and password, what JavaScript is going to get executed. You can see it over here. So say for example, we analyze one of the script. Let's try this. So over here we are saying, okay, I have a login button over here, and I say, okay, start DOM tracer. So we start DOM tracer here and say, okay, start trace calls. And we say Shreeraj, username and password. We pass on that. And now we can see what has happened at the back end. The browser has, first it has called a function called get login. the function get login has been called. These are the lines which were extracted or executed. So as I shown you that, and then you have a temp function where username and password is taken, and then some kind of a callback came back, and the XML HTTP response has been posted back over here. This is a single DOM application. So now pretty much anywhere you find a cross-site scripting, you can do alert temp here, for example. So we did an alert temp here, and you can see the username and password pops up. So we extracted that variable here. Now say for example we do image src foo on error alert temp variable. So now we know that there is a temp variable which is of our interest, and we try to extract that here. So as soon as we do this, you can see I can see the username and passwords over here. So this is a way how if you analyze the application, if you see all the global variables, you can start extracting this information. For example, let me show you a very quick way of extracting global variables. Okay, so here is a live application. Okay, so here is a, for example, if I go ahead and say Shreeraj and I say login. Okay, and you can go to the bookmark. There are some bookmark out there. I forgot the site, but there is a JavaScript which will show you all the variables which are loaded in the DOM. So if I go to the dev and say list view variables, it's pretty simple here. You just do a loop in a Windows and say show me all the variables. So you can see straight away the temp variable over here, and all these are different variables. So try to see this, like it is a very hilarious when you see some of the sites which are storing various different IDs etc. in the global variables. So these global variables are extractable when a cross-site scripting or any way you get access to the DOM. So this is a one way how one can start stealing information from the browser. Second area is the same concept applicable to RIA application, which is running on a Flash or a Flax. So you have a Flash or a Silverlight running in the browser. It is essentially sharing the same DOM. So you have like the whole DOM, and then there is a one piece of information which is running in the Flash. So DOM-based cross-site scripting can retrieve a variable. So like your DOM-based cross-site scripting will actually go into the Flash and retrieve a variable from the Flash and send back. So like we retrieve a variable from the DOM, we can retrieve a variable from the Silverlight or a Flash as well. In some cases, depending on the scope, one can craft attack and retrieve these kind of information. If these files are using parameters, then it's essentially possible to exploit. So it's pretty simple to decompile files. So like say for example, if we go ahead and see, this is a simple file, a Flash based or a Flax based file we have over here. We can go ahead and see, okay, there is a Flash movie over here, and there is an inventory.swf file here. So we download the file and say, okay, use swf dump, and there are various different decompilers out there. So this is your decompiler. One of they say, okay, dump the whole SWF into this. You can see services, you can see various different stuff over here as such. And then over here you can see various different backend calls. And now you say, okay, show me all methods, show me all public variables, show me all variables, whatever on that. You can see all the list over here, and then whatever you find interesting, actually you can retrieve once someone glue to the Flash application, enter certain information, you can start extracting that. So now what we can do is we can do a cross technology access where we exploit the XSS. So say for example over here we have a login form over here. This is now this little form is actually the Flash based application, so it is is a part of the Flash. We say, okay, I did my username and password. Now on the Flash we are successfully logged in. So over here we have a successful login, and then we click here, for example. So as soon as we click here, you can see the actual username and password and the token, because what we have is like we can decompile the Flash, identify the parameters which it is using inside, and then start retrieving those parameters. So if you do page source here, you can see over here we are saying, okay, windows.document, then do a login and get variable names, passw, token, etc. This is essentially you have retrieved from decompilation method. So this is how a DOM based cross-site scripting or DOM based attack will start start interacting with the flash or start interacting with the with your Silverlight as well. And in some cases, the cross-site flashing can happen with the DOM-based vulnerability. So say for example, you have a file here which is a URL over here. You can see there is a HTML which is actually loading the movie which is coming from the third party. So when you look at the source, it is using a call called document.write and then rewriting the whole DOM. So now over here, what we can do is we can, instead of this particular file, we can pass on a file coming from a malicious source. Say for example, instead of a 55, I change the IP address over here, say 58, and then that will actually, that particular file which is a cross-site flashing where we are using a get URL or any other call, we are retrieving JavaScript variables out. So we are running a JavaScript through the flash and such. So this kind of cross interaction would happen with the DOM. And one of the interesting part here is you have a single DOM is now loaded, and when you do a DOM-based cross-site scripting, it is going to be permanent there till you move out from the browser instance or you move out from that particular page. In persistent or a non-persistent cross-site scripting, essentially you have to be on that particular page till that point the script is going to get executed. So over here what is going to happen is you log in and some kind of a cross-site scripting is already done. It's still listening, it's still there, and still you are functioning and you are doing some other part in the DOM. So pretty much you get a permanent access to that particular application's DOM till the point browser or that particular user is executing stuff on that browser. So these are the two categories where DOM-based cross-site scripting and then DOM-based stealing, which is going to happen with the AJAX or with the DOM JavaScript variable, or you can access Flash and a Silverlight. Okay, third area is a widget hacking. Pretty simple. We have a lot of different application nowadays we are reviewing, which is running with the widgets, gadgets, modules, depending on the name you take. They are essentially a small JavaScript programs which are running in the browser. So all of a sudden your application is no longer a single threaded application. In the browser you have a multi-threaded application running. You have like a 20 little application running in the browser, and then each application would be making an asynchronous call at the back end so it won't stall the browser. So you can do a multi-processing from the browser. So JavaScript and HTML based components there, in some cases it shares same DOM. That's the problem. When you have various different widgets running in the same DOM, that's the biggest problem, because now what you have is like one widget can access the DOM and the second widget is running in the same DOM. It can cause a cross widget channeling, and there is a lot of different exploitable possible. So say for example you have a widget architecture where you are saying, okay, I'm interested in this widget, load this widget. I'm interested in this widget, load this widget. So you have, for example, over here you have three different widgets. Widget 1 is an email widget, widget 2 is a RSS feed reader, widget 3 is an attacker widget, for example. And you are using a same DOM, or you are using the shared DOM or some area of the DOM as such. So now what can happen is it is possible to access DOM events, variables, logic, etc. So if there is no architecture layer sandboxing done, no DOM segregation using iframe is done, or some type of flash based widgets would have access to a DOM. So this kind of a vulnerability only you can find when you do a code analysis. So cross widget spying, for example. So over here what you have is a little widget. So there are 5 or 6 widgets over here, and now you look at like someone is actually just, what we did is like we just did a mouse over from this. So like the mouse moved from this particular widget. So this is this particular widget is a, say for example, malicious widget, and then there is another email widget where you pass on your username and password credentials here. Now what happened is when you pass a mouse from this widget, it has set up a trap on these two fields. So then as soon as you pass on your username and password and do a on mouse out, so it's like just you are doing the on blur, event will fire and it will take your username and password from this widget and send it to http://attacker.org via proxy.aspx. So this is how you can now stealing cross widgets. If your architecture is not supporting this, your one malicious widget is actually monitoring the other widget. And interestingly, this is one DOM application. So this widget, whatever you have loaded, is live for the rest of the application. So there is a larger scope involved here. So this pretty much like someone would be able to retrieve these username and password information over here. Now say for example, we use the tracing. So we want to see what is going at the back end. So we use our DOM tracer and try to figure out what kind of scripts are injected, etc. here. There is a little plugin which will show the widgets here. And you can see we started DOM tracer here. And now we say, okay, start trace here. And now we are just putting a mouse there. So now you can see as soon as we pass the mouse, it has registered an event in the DOM which say reg event for me. And that particular call is going to put a strap on these two fields, document.getElement text user, text password. So these are the functions which are actually listening for as soon as someone enter username and someone enter password, they are listening, and once mouse go out, it is going to call a function called getP. So then this is what we have over here. And now as soon as we pass on over here, we pass on Shreeraj, we pass on password, and we do a mouse out. You can see the event is fired and the getP function is called. It has taken my username and password from this widget, sent to out. So this is how, or you can go ahead and start analyzing the script. You can analyze this. Say for example, this is a widget site, then you can start analyzing how the widgets are interacting. So you can do a DOM scanning here, or you can actually load the DOM here. So now the whole DOM is now loaded. You can see what scripts they are using for this particular architecture here, whether the sandboxing is done or not, the widgets are running in their sandbox or not. So you do a document.call analysis, and it will show the virtual lot of different DOM calls. We are interested in map.js, and you can see it is using document.getElement over here and such. So again, there is no black box scanning here. You need to do some kind of a white box analysis. You need to do some kind of a script analysis, or you can do a dynamic analysis using DOM tracer. You say, okay, if I'm doing something in this widget, what kind of a backend call is going, whether it is you loading new frame or not or such. Okay, so that's a widget. Second is the feeds and mashup hacking. So feeds and mashups are pretty much very popular. Feeds are RSS or atom-driven components or atom-driven structure, which is essentially XML document which comes back in the browser, get loaded. It tunnels through the application. Essentially over here, the problem is RSS feeds which are coming and get loaded in your browser are coming from untrusted sources. You have application which say, okay, any RSS feed you can subscribe. And mashup are a man in the middle. Essentially, mashup application is like a one application created from multiple applications. So again, a lot of untrusted sources involved here as well. So this combination is essentially open up the attack surface in 2.0 application. So over here, what you have is a web client will make a AJAX call. It will go to the proxy. Proxy will go on the internet, get whatever information you have asked for. It is coming from untrusted sources. It's coming from the unknown domain. That script will come, and then the new content will go into the current DOM. So for example, if someone has injected a malicious content in the RSS feed, so that feed will come and get loaded here, and as soon as you click a link, you are going to get cross-site scripted over here. So say for example, if we look at here, so here you have like a trade news. You click a news and you can see a AJAX call which go out to a CNN feed, getting the feed for me and showing me over here. So this is how the feeds will come back over AJAX call. And as you can see, this is like a DOM. There is just this tiny piece of information has changed. There is no refresh and reload. So whatever new content coming is getting loaded right here. So now we have this whole different script. So now we'll want to look at that. Okay, show me where this little feed. So it is going on change get RSS feed. That's the call which is going, and there is a feed LB over here. So now what we're going to do is we start our DOM tracer and try to see what is going at the back end. when I script or when I make a call. So DOM tracer will show me all the links, or DOM tracer will show me all JavaScript lines which are executed. So you can see the first function which was called is a get RSS feed here. It will call this function and grab LB feeds. That's from where the feeds are coming. It will make an open call, make a get request, and grab the whole feed for me, and then it will start processing RSS place. The place is defined, a placeholder is defined. So we grab that document.get element, and then we do reloading of that part of the document. So we run a loop here which say, okay, get element from my XML document, and then we say, okay, change my inner HTML here. Now you can see over here in this place there is no validation. So whatever content which is coming from RSS feed is just served here. So be it a link or any content which is coming is going to get loaded here. So now if we go back and we say, okay, grab a link, get this mynews.org which I registered for the feed. So I grab the news from there, and you can see over here someone has put a JavaScript :alert XSS. So that has been posted as a link. And so as soon as I click on interested news item, I get cross-site scripted or DOM-based cross-site scripting. Combination of attacks is happening over here. The information is coming from untrusted sources. It is going via XML. The XML will get loaded in the browser. The parsing will happen. During the parsing, it won't do any validation and load the content. And I click the link, and it's going to do a XSS. A similar thing is possible with what you have over here is a mashup application where you say, okay, these are the two applications, eBay, show me eBay on Google Maps, and then show me a profile of the person who has posted this particular product, for example. So you have this Jack's profile here, which has been posted here. So now, as soon as I click on John's profile here, it will pop up and show me that profile here. Again, a DOM-based stuff is happening at the back end. I click the link and get cross-site scripted. So these are the mashup hackings. Again, over here, what you have is information coming from untrusted sources, and there is a possibility of making a cross-domain direct callback. That's pretty complicated, but it's pretty much possible where your proxy will not come into picture at all. Okay. The next attack is a CSRF. So you have a cross-site request forgery, but this cross-site request forgery, we are talking about XML stream, AMF stream, JSON stream, etc. We are not talking about the traditional cross-site scripting here. Briefly, there is a same origin policy where protocol host and ports are matched, and it is possible to set a document.domain to a parent domain if a current context is in a child domain. So that's again one of the abuse which can happen when someone will change the parameters on your document.domain, and then top level TLD locking down helps in doing the sandboxing. So that's the fundamental where browsers are following same origin policy. But then there are abuses out there. Application running in maybe a subdomain. So you can load something in a subdomain which get loaded by CSRF. What if document.domain set to about.blank? So there is a pseudo URL mechanism there, or DNS rebinding if a DNS or IP resolved to one-to-many. So there are some attacks there, and then you have already bypasses there via script, image, iframe, action tag of form, etc. These allow you to make a cross-domain calls. So CSRF is possible with the Web 2.0 stream. So DOM is making a backend calls over here with the JSON, or making a call to the XML or etc. So we try to see that whether you can do a CSRF over JSON or you can do a CSRF over XML, and we figure out how it's quite possible as well. So what is going to happen is, say for example in this particular condition, application user will go to this particular trading portal and say, will do authentication. So once it's authenticated, it is still browsing around. It will go to the attacker site, and attacker will send a CSRF payload which is in HTML. That HTML get loaded in the browser, and as soon as it gets loaded in the browser, it force XML call. This is not a typical get or post where you are posting things on a name value pair. You are posting XML content, and then that order will get placed. Now this XML content can can be JSON, this can be AMF, this can be typical XML, etc. So say for example this form, what we have done over here is we created a hidden value, input type hidden, and when we put the whole JSON envelope here and say value equal to foo, and then we say document.by.submit. So when you do this, what is going to happen is this kind of a request is going to get generated in the browser. So browser will generate a backend request to json.jservice.ashx, and this can be to any domain. You don't restrict it to your own domain because it's an action tag. But two important features over here, you can see the content type is text plain because the form cannot generate text/XML or text/JSON. And then you can see the whole XML or whole JSON, the way we want to do a CSRF is generated at the back end. You can see equal to foo is posted by the browser. Now what we have analyzed is there is a serialization which ends right here. It say okay, I'm looking for, I will start and counting a serialization as soon as my all curly brackets are over, I will not process the remaining string. So this is not a well formatted JSON, though it's get processed on the server side, and we get this kind of a response back over here. So this is how you can do a CSRF on the JSON stream. Or for example, we have XML. So same fundamental you can apply to XML, and what we have done over here is we put a half of the envelope here and then remaining half of the envelope here, and then we say document.by.submit, and the equal to sign like version equal to 1.0 will get injected by the browser. So say for example, let me show you a demo here. So you have like a trading portal over here. You are right now on mytrade.com. You can see it is a mytrade.com, and you're passing your username and password here. You say okay, John is my username and password. You say okay, it's a JSON stream which is coming back, and you say oh, your user is authenticated. So once user is authenticated, it's trying to place an order for a stock. It say okay, place an order for symbol Microsoft and some quantity. So I say okay, 25 stocks of Microsoft, post that order. So the cookie will automatically replay here, and you get a response back which say okay, this is my request actually. This is my request, which is XML stream. You can see order for 25 has been placed, and I get my response back here. Okay, so this is my response, this is my request, everything is fine, and my order is placed. Now this is mytrade.com. Now you visit mytrade2.com. You can see over here it's a mytrade2.com, which is completely different domain over here, and you are on the login page. This is just essentially to post a link. I have posted, else it's completely happened without your consent at the back end. So you click that link here, and you can see mytrade.com login, and the whole XML has been generated. So you visited mytrade2.com without your consent, without your knowledge. Since you are already authenticated on mytrade.com, XML stream generated from your domain and injected into the mytrade.com domain, and your stock, whatever stock you want to place, has been placed by the browser. Now if you look at the source of the page here, okay, so here is a page source where you have text plain, hidden, XML version equal to this, and the remaining envelope has been posted here in the XML stream. So this is automatically the DOM will call, the function will get called, cross domain will get generated, and you get cross-site request forgery on that particular piece. So now you have CAPTCHA or whatever you are putting in, and if the stream is JSON, then you have to make sure that you send a token and then process the token at the back end to protect yourself against these sorts of attack vectors. Now one of the thing over here is that the server side haven't checked our content type. If it was checking that okay, I'm expecting XML and in my content type it is text XML, then and then you process, then this attack would not be gone successfully in. But a lot of libraries, a lot of developers are not checking that, whether it say okay, whatever is coming on this page is going to be the XML. I don't want to check whether the browser is generating a text XML or text plain. And finally, coming to the DOM reverse engineering. So what now we are trying to do is it's pretty easy to reverse engineer DOM. What is happening in your DOM? We have already seen two tools here, DOM scan and DOM tracer. So it is easy to do a reverse engineering if a JavaScript, then possible to debug. If it is using Flash, Silverlight, then again you can do a decompilation and try to analyze them, and it leads to possible vulnerabilities or exploitation scenarios. Now, one of the observations which we have made here is that with the 1.0 to 2.0 application, what we are seeing is like we had this traditional layers like utility, access, business, app presentation. But with the 2.0, you can see this kind of a yellow layer. When in a JavaScript, certain part is a presentation layer. Some of the business logic which is supposed to be on the server side is now moved to the client side. And then some of the application are making a direct data access call from the AJAX as well over a SOAP pipe. So now we have the shrink of this layer, which allows attacker or analyzer to see what is going at the back end with something which was supposed to be executed on the server now executing in the browser as such. So this is where we can do analyzing of a JavaScript and access logic bypassing. So say for example, this is our application where we are doing a Shreeraj, we are logging into the application here. So my username and password has been sent here, etc., etc. So the page has been loaded in the DOM here. Now I go ahead and say, okay, show me, I'm starting DOM tracer. I want to see what is happening at the back end in the DOM. So I just started the DOM tracer here. And then I go ahead and click a bank info function. And you can see in the bank info function, some number is going. So I'm interested that what is happening when I click bank info. So in a get bank info, this particular function called some kind of encryption or is happening or encoding is happening, and then it takes my username and craft that back to this application, and application will revert back. So these are some of the business logic which now you're seeing, and these kind of tokens which are getting generated here. So now I'm interested. So now what you can do here is like little JavaScript shell here, which is essentially comes with a Firebug. Whatever functions are here, you can start accessing from here directly. So I say, okay, forget, like I want to make a get bank Shreeraj. So I do that, and you can see as soon as I run this function, it will make a get request here, and it will going to show me. Now what if I start changing values here? So I say, okay, Nisha, and you can see the value changed here. Now I can start receiving others account information here. So instead of a Nisha, I say, okay, Hamil. So now I'm seeing his banking information. So these are the functions. Now you don't have to log in some cases because these functions are already exposed in your DOM. So you can start making these DOM functions. So these are some of the interesting things which we are seeing in 2.0 application. Another thing which we are leveraging is a debugger. So you have a nice Firebug has a nice debugger here. So now we are making this same function call, same discovery here. So now we say, okay, show me that function. So now in the Firebug, you can see get bank info here. And I put a breakpoint here. I say, okay, I'm interested in changing certain things here. So I say, okay, set up a breakpoint here. And now I say, I click the function. Okay, so now you can see what is the parameters over here, and I can start changing here. Instead of a Shreeraj, if I put a Nisha here. So at runtime, I'm changing the values in the DOM, which you can do using Firebug debugger. Or you can do a decompilation attacks as well. So you say, for example, here is a sample Silverlight file. What you can do is you download the file, and there is a XAP file. You take XAP file, it's nothing but the archive. It's a zip file, changes extension to zip. Unzip the file here, and then you can start seeing all JavaScripts, all DLL, etc. And if you are more interested, take the DLL and pass it to the RaidGates or Loots decompiler or any other decompiler, and you can actually start seeing the actual source code of the page as well. So now if this particular piece of information has something which is interesting on the server side, then actually you can decompile and try to analyze the file. So our focus of these analysis would lie on more on the DOM. So we try to see DOM calls going from the Silverlight to the DOM and DOM to the JavaScript, etc. So these are the some of the attack vectors, be it DOM-based cross-site scripting, stealing variables, hacking mashups, hacking feeds, lot of different 2.0 components, which is leveraging widgets and such. So there are countermeasures out there depending on. So first and foremost is when you develop, deploy, design, or analyze application, do a threat modeling or threat analysis from the DOM perspective. Sometimes you need to do a JavaScript code analysis, which you can do using DOM scan or any other tools. Source of information and dependencies analysis, which one needs to perform. If you're doing a proxy level call, say your application is actually calling a proxy will go out, fetch information and tunnel that information. You need to do a filtering there. Whatever content coming from the cross domain should not be trusted for your end user. You do filtering and then pass on. And this is very important. Do a content type check or restriction. Like before processing a content on a server side or a DOM side, make sure like you have a content type is text XML and you are getting the text XML content. And then securing a DOM call, so document.write, eval, etc., whatever calls you are making. So that's pretty much countermeasures. We can discuss more countermeasures. You can do a lot of academic analysis on it, but in a nutshell, this is what we want to achieve. We want to have our DOM call secure. We want to have our content which is coming into the DOM filtered, or not any explosive content which is coming into .o application and executed on the DOM. Okay, so that's pretty much it. In conclusion, we have covered various different DOM-based attacks, and as you see in the 2.0 application, as I discussed the first part of the presentation, where you have a single DOM application, 2, you have various different streams which are coming in, and 3, somehow you have to take this stream and inject into the existing DOM, which makes the combination of a 2.0 application vulnerable. It opens up a new attack surface, new ways of attacking application as such, and you need a better approach. You need a different way of analyzing application, be it using a DOM scan, using a DOM tracer, or any other way. And I have seen that these kind of applications are so complex to analyze. A black box scanning or scanning application will not work. Like some kind of a human tracing, some kind of a human analysis is required. And looking at the widgets and such, you need to do some kind of architecture reviews on the application before publishing it out, else it come up with a lot of different XSS and a lot of different DOM-based issues, which are happening on the client side, but it has impact on the server side as well. So that's pretty much it. You can see my blog at blogspot.com. You can email me if you have any question, and you can go to the blueinfy.com/tools.html, where this particular tools are already uploaded. So we are releasing these new utilities or tools. Okay, so you can download these tools, DOM scan and DOM tracer. Both are still in beta, and we have a lot of ideas for it as well. So we are going to utilize and try to make it more powerful. Another tool which we have is called app code scan. This again you can use for static analysis of a JavaScript. We have some rules there as well. So that's pretty much it. Any question? I'm pretty much open for any question. We have 5 minutes. Okay, any question? It's slides in the videos? No, demos are not available. Slides are already in the CD. But not your demos? No, demos are like, it's pretty big ones though. It's not posted on anywhere. Some of the demos are part of my books. So if in the books there is a CD which are published with both the books. So some of the demos are from that. Okay, thank you very much for listening to me patiently.